Hi, it has been almost 1 year since Andrej Karpathy released this legendary video on building a GPT from scratch. It has 4 million plus views and it's 2 hours long. For anyone interested in knowing how to completely build a GPT from scratch and also to learn the fundamentals behind GPT, I highly encourage you to go through this video. The purpose of my video is to teach you how to use the NanoGPT repository hosted by Karpathy. This has so many stars and forks. So I'll show you through my video how you can run this code and how you can basically, so what he does in his code is he takes the work of Shakespeare into a text file and trains a simple GPT on his own computer. I think he has a GPU. I will be training without using GPU, so I'll be just using CPU. So the parameters that I use while training, I'll be kind of using trimmed down version. So, the GPT, whatever we are building here will not be very accurate or it may not give very good output. But basically the purpose of this is first we will train the GPT on the work of Shakespeare and then we'll try to produce some outcome based on the training data. And after that, we will see how we can train the same GPT on other data like Spotify song data set, like lyrics. So we can train the GPT on lyrics of many different songs and see how we can generate new lyrics. And also we can see how we can train the same on Harry Potter textbook, Harry Potter novel, the TXT version of that, and how to create something new after the training is done. So let's see how to do this. So first head on to the this GitHub repo. I'll share the link in the description, or you can manually type this and you can fork it for yourself. So let me click to fork. Okay. So I have successfully forked it, and let's just scroll down to see what all things are we supposed to do. So we have to install a few different packages, and we also have to, there are 3 different steps. So first we run this to prepare the data set. So we fetch the data set from a URL and then we split it into training and validation. And then we train the model, and then finally we try to generate some output based on the Shakespeare's data. So this is what these 3 steps will be doing. And if you have a GPU, if you can train to have a very low validation loss like this, probably you can get output something that looks like this. This is pretty good. On the other hand, if you don't have, we can, instead of running this piece of code, this piece of line, we can run something with slightly notched down parameters, and this can be done on the CPU itself, so you don't need a GPU. It might take a few minutes to run, but that's okay. And this might produce output like something like this. So let's see how how to implement this whole thing, and also how to do the same thing on our own data set. So let's go through that. So I have forked this. So let me copy the HTTPS and I'll go to GitHub desktop. So I use GitHub desktop usually. So I'll just create my remote version of the repository. All right. So clone repository and URL. I guess. Oh, let me just make sure I have deleted I already had forked it once. So let me make sure that locally I have deleted it once. So hopefully it should be fine now. Yeah, because this path was already existing on my computer because I had tried this before. So I deleted it. So now I'm starting from scratch and clone. Okay, so cloning is now successful. So I'm creating this for my own purpose. So I don't want to contribute to the parent project. So continue. And I'm on Mac. So I click Command Shift A so I can open this in Visual Studio Code. I have VS Code already installed. If you don't have it, you can install it. I don't want to go through that in this video because that will make the length of the video unnecessarily long. But let's go through the steps to run the code. So first, let's have a look at it, right? So this is the piece of code that trains the model. Then config files are here, meaning configuration for running different parameters of different levels. So we will be using this not now. We'll be using a different version of this when we are using our own dataset, not Shakespeare dataset. So initially we'll be running this Shakespeare character, and the dataset is this text file basically. So we'll be fetching the dataset from here, creating a training and validation data, and then let's try to run, right? So let's look at the GitHub repo once. Okay, so what I will do here is I will first create a virtual Python environment because I don't want to install any packages globally. I just want to install it in my virtual environment. So let me just find the code for creating the virtual environment first. Okay, so this is the code for my virtual environment. I'll just give the permission yes. And we need to activate this environment, and then it will appear here in the bracket. So this is the code for that. I just copy pasted it. I had written it in a document. So now we'll be using this virtual environment, and then what we do is we install different packages that we will need, because none of these packages will be available in the virtual environment. You don't have to follow the virtual environment route. I just do it as a practice. So let's first install these torch, numpy, transformers, datasets, tick token, all of these. Hopefully it should finish without any issues. I'll just pause the video and come back once the package installation is finished. Okay, so the package installation is finished. Now let's install the first part. So there are three parts that we'll be running. First is fetching the data and creating train and validation. So first let us run this. We don't need to copy the dollar symbol. So that's why I manually copied. We can do this, or you can also go to this folders and click prepare engine. You can just click here to run. Both of that works. Hopefully this should run without problems. Let's see. Okay, so it ran, and you can see that this has created the input.txt and training and validation. So these are the training and validation sets, and let's open this input.txt, which was taken from this URL. So these are all the different Shakespeare's work combined into one text file. You can read it. It's very interesting, slightly different type of English. Okay, so this first 1/3 of the steps are done now. Now what we will do is to do the training. So for doing the training, I will not be copying this part of the code because this will need GPU. Rather, I will go down here and I will use this section of the code. So I'll be running on parameters with slightly, notched down parameters. So I copy paste it here, and yeah, then I will run this one. Hopefully this should work once the running of this code is finished. So I don't know how much time it takes to run, n number of iterations. We'll see how fast the training is happening. And if we don't want to wait for all the iterations to finish, so here we can see that there are 2000 iterations. We don't have to wait for all 2000 iterations to finish. We can also pause after 500 iterations. So on Mac, I can just press Control C to just stop the running. So here you can see that it's kind of fast. 50 iterations are already done. You can see the loss is decreasing. Initially it was 4 point something, 4.1, 4.2, and it has already decreased to 2.5. So this is going good. Maybe I will wait, since it's anyway going this fast, maybe I will wait for all the 2000 iterations to finish. And I will post the specs of my MacBook in the description. So if you want to compare how fast the running would be for you to get a ballpark estimate. So I'll pause the video. I'll come back when this is iterations are 2000. I'm also interested to see how much the loss will decrease. So let's come back once the running is done. The iterations are about to finish. We are at 1999. Okay, 2000 iterations have been finished. It took totally around 3 minutes, something like that. So not too much. You can easily run 2000 iterations. Okay, so step 2 out of 3 is done. Now let's look at the last step. So last step is this, copy paste this. So we'll be creating, let's open the sample.py. So this is the sample.py, right? So we can create a new sample based on the training that we have done using the input.txt, which is the Shakespeare's work. So let's see how good the output is. I hope my font in the terminal is okay for you, like visibility wise. I can increase it a bit. Okay, so here is the output. It's not very good, but it's also not as bad as it could be. We just spent less than 5 minutes on this whole thing, right? So it's decent. Some of the words I don't think they have any meaning. Like I don't know what's the meaning of this word. It's like a semi-English thing, whereas in input.txt you can, it's pretty much normal. Like most of the words we already know, but some words look a bit odd to me in the original input.txt, the original Shakespeare's work. But here you can see the way it has created. So see in the input.txt also there is this capital letter. I think it's the description of that. I think this is the name of the person, right? Probably, yeah. And here also the generated output is following that pattern. So this is pretty good. So you can also follow the same steps and run your version of the NanoGPT from scratch. What we will do next is, let's see how we can do the same thing instead of using Shakespeare's work. Let's see how the same thing can be done for another data set. So we'll be looking at a Spotify music data set. So I'll show you the link and where to open it. So if you Google Spotify million song dataset, you will find this. So click the Kaggle link to open. The dataset is there on Kaggle. So here you can scroll down. So this is the dataset, and these are the different columns: artist name, song name, link to the song, and lyrics of the song. So these lyrics, this is what we are interested in. So what we will be doing is we will combine. So this is in a CSV format. We will first try to convert this into a we will combine the values in the lyrics column into one single string, and we will use that as the training data, and then we will try to generate a song lyrics as an output with some parameter as the input. So let's first download this. This is, if I remember correctly, yeah, 75 MB. So after downloading, what we will do here is here in data, we can create a new folder called Spotify. And here, here we'll paste the CSV file first. I have pasted the Spotify million song data.csv here. And the format of this is pretty much similar to this. It's a little bit big file, so opening might take some time depending on your computer configuration. Next, what we will do is we'll create a similar prepare.py file here. So .py, and then what I will do is I will copy the content of this Shakespeare char into this. Okay. And after pasting this, let me just delete all of this. Our data is not the Shakespeare's data, right? Our data is from the CSV file. So we can delete a bunch of lines here. All we need is so first we need pandas PD, and since I'm working in a virtual environment, let me install it. I think I have to use pip3 because I'm using Python 3. I'll try both, whichever works. And okay, so that is done. Now what we should do is we want to extract this lyrics column from this pandas. So let's do that. So I have pasted the code for this. So firstly, let's read the CSV file. So our path is data slash Spotify slash okay. So and then what we do is, so once we read the CSV, we extract the column called text, and then we join that into a string with the slash and next line character as the separator. So let us do this. I think this should be named as data, I guess, because we are using it later. Let me first try to save this and run and see what happens. I hope it runs. If not, we'll figure out what's the issue. Okay. Okay, so this has been created. We have the train and bin over here. So I guess this was successful. Let's see. Okay, so the first step is done, which is preparing the data. Next is training. So let's do this. Let's create in this config file train Spotify.py, and for this I will copy paste the code from the train Shakespeare char.py, and the output directory could be out Spotify. Then the project is Spotify. Paste it here. I think that's all the change. And now when we run this, hopefully it should create the output directory and everything. So let's copy the code for training. This is the code for training, right? So okay, paste it here, but we have to delete this part, sorry. Let me just paste it again. I'll do one thing. I'll paste it here and I'll keep this ready. So instead of train Shakespeare, it is train Spotify. And everything else is fine. Okay, paste it here and run it. So hopefully this should work. So our train config is over here, right? So that's why we changed the train Shakespeare character.char.py into train Spotify.py. Okay, it's running reasonably fast. And again, this one we are running for, I believe, 2000 iterations. Yeah. If we don't want to run for that much, we will of course pause it in the middle. Currently this is running somewhat fast. The loss has started from 4.3 and it's already down to 2.3. I will do one thing. I'll wait till 2000 iterations are finished and then we can come back and check what kind of output we are able to produce by training using the Spotify dataset. So I'll pause the video and I'll come back so that I'm not making the video length unnecessarily long. So the running has finished. It took maybe 3 minutes again. And now let's copy paste the generation part. So here the output is I guess Spotify. And one more thing we'll do here is we'll give a starting probably I can do it after I paste. What we can do is we can provide start equal to, just thinking of some maybe sunset. Let's see what the output looks like. Oh yeah, so this output directory was created when we ran the previous, this training code. So here is the new song lyrics that this has created. Let me see how good this is. Sunset. I don't know what this means. And now you don't what you work. The grammar is completely off. But yeah, I mean, I don't know where is the sunset in this. Only the first, this has sunset. But everything else is not related to, okay, there is another sunset. Sunset the coup. Yeah, I mean, it's doing something. I cannot vouch for its quality, but it's something. So this is exactly how you can train on your own data. I would love to see what's the output like if any of you can run this on a GPU and share the kind of songs that this is producing. But yeah, this is how you can do it on this data. I'll just show one more thing. I'll show how the same thing can be done on a TXT file where we have collected Harry Potter novel, right? So let's do that. All right. So first, again, let me create a Harry Potter folder here, and I'll paste the TXT file here. Okay, I have pasted the TXT file. So this is Harry Potter and the Half-Blood Prince. There are different chapters. Maybe I'll just rename this as harry.txt for ease. Okay, then what we should do is we can copy paste this prepare.py here. And since we are not using the TXT file, what we should do is we should take the input from this TXT file as a string. So let's do that. So instead of, I'm just pasting the code for, just delete this. So file path is data/potter/harry.txt and file contents is file.read. So I guess all we need to do is define this as the data. All good. Okay, so now let me try running this. Hopefully this should work. Let's go back here. Prepare.py. So, okay, I can directly run it here, I guess. So let me go down here and let me just run this. Hopefully this should work. Okay, so running was successful. So looks like train and validation is created here. So okay, that was good. Now what we will do is we will copy paste this ones here to create train Harry. Okay, so in train Harry output we can create in a folder called out Harry, and the project is called Potter. Okay, so that is also done. Save this. Let's copy the training command. I guess I can copy it from here. So train. Okay, again 2000 iterations. Hopefully this runs, and maybe this will be faster because I don't think the txt file is as big as before. Yeah, let's see. Okay, so this is running. The training loss has started from 4.5 and it's decreasing. I'll again pause the video and come back once the 2000 iterations are finished. So let's come back after that. 2000 iterations are finished and it again took only 3 minutes. Now let us run this. So sample. So output directory is out Harry, I think. Where is that? Yeah, out Harry. And we can just run this. So again, I am running everything on my CPU. I'm not using GPU. So most likely you should be able to try the same. Yeah. Oh, I did not give the starting word or the cue. Let me just try that. I don't know how the output is going to change based on that. It's creating something for sure. This now looks more like a novel. The first one was definitely looking something like a Shakespeare's work. Second one was looking like a song lyrics, and now this is looking like a novel, although I guess it's not grammatically correct or anything. So maybe what should I type? I should just type something interesting. I'll type snape or something like that. Yeah, I don't know what is the word, whether this even makes sense to type to generate, a new story from one word. Probably it makes sense for more for lyrics of song, but maybe for this it does not make any sense. But yeah, I mean it's using that word here and there. Not too bad. English grammar is really bad for sure, but overall for our CPU power, I guess this is good. So hopefully you got some idea of how to use your own dataset and do the training. I'm very, very curious if some of you can run on GPU and show what kind of results you are able to get. If you can paste the song which you created or the text story or anything else which you created based on your GPU running, I'll be very curious to see that. So here in Andrej Karpathy's GitHub repo, you could see this was the kind of output you got after training using a GPU, and this was quite good. So if I can see similar versions of samples based on Spotify dataset or Harry Potter or anything else, that'll be very interesting. But so hopefully this brought you some clarity on how to run this notebook and how to look at it from an application point of view. Of course, this does not mean that you may still understand the basics of building a GPT from scratch or transformers or anything like that. So I highly recommend you to go through this video. It's a beautifully done video. The comments are all, you should definitely read the comments. I mean, it's very, very inspiring, and people love this video really. So please go through this and let me know what else would you like to learn as part of large language model or generative AI or GPTs. So thank you so much.